Hey guys, welcome to PreCalc online on the internet. I'm sad I don't get to be with you guys today, but I hope that you're doing well. And I'm excited to hang out virtually, I guess, and do our lessons and notes and stuff online. So if at any time you need help or anything from me, you can always email me. You can Google Meet me. I'm always going to be available during our class time. And if you need to talk to me outside of class time, just communicate it. We just have to over communicate the next few days while we're kind of in this like weird area. But I am always here for you, and I want you to be learning and doing your best, even though I don't get to see you face to face or in person. So here we go, day one of e-learning. Again, if you ever need me, let me know. So we're starting with a review. We started chapter 6 last week. We did 6.1, and then we did the beginning part of 6.2, I think before or after our quiz that we took last Wednesday, I think. And so we're going to start with a review. So I want you to pause the screen, and I want you to see what you can do on your own. A little disclaimer, I'm trying as hard as I can. This is not neat. I recognize that. I'm going to mess up, so please be patient with me. And I'm sorry for any mistakes that happen or anything that you can't read. I really am trying my best, even though it doesn't look like it. So pause your screen, try this review. Okay, and now that you've paused it and you've come back and you have all the right answers, I'm going to go through all of them and you can check them, okay? So we're going to start at the beginning. So if I just ask you to do the vector of BA, first thing we have to do is y2 minus y1 over x2 minus, or sorry, not over. We got to do our x's first, so I've got my 1 minus negative 2, and then I've got 5 minus 0, so that gives me 3 comma 5. Awesome. Not too bad yet. Now we're going to add two of these together. We already have BA, so why am I going to do this work all over again? I do need to do AC though. That has not been solved yet. So I'm going to do AC. I'm going to do it in this orange color. So I have to do 7 minus 1. And then 3 minus 5. Seven minus 1 is 6, 3 minus 5 is negative 2, so I'm going to combine BA, which is 3 comma 5, add that to 6 and negative 2, so 3 and 6 combined to be 9, 5 and negative 2 combined to be 3. So my answer for this one is 9 comma 3. Okay, keep moving on. Now I have to do 2 AC and then negative 1 AB. So I already have AC, so I'm going to do 2 times AC, which was 6, negative 2. So that becomes 12, negative 4. AB, we already did BA. If you do AB, you just have to do negatives of each term. So since you're going in a different direction, instead of going like from B would be like negative 2, 0, and then A would be over here. Instead of going from B to A like this, we're going to have to go backwards. So I'm going to go A to B instead, which means I'm going this way and my arrow is going that way. It's the same distance, the same vertex or vector, excuse me, but you got to make it negative. So I can do plus negative 1 times negative 3 and positive 5. Which luckily enough is going to be the exact same thing that we started with. So it'll be positive 3 and positive 5. And then when we add those two together, it will be 15 and positive 1. That's our vector for that one. All right, now number 4 is talking about the magnitude. When we have these absolute values, we're doing the magnitude. Again, we already have BA. Let's work smarter, not harder. And so I'm going to do 3, 5, and so we are going to do our magnitude of that. Square root of 3 squared plus 5 squared is going to be square root 9 plus 25. That's going to be square root 34. Luckily, we can't simplify that. That's as simple as it gets. Number 5 is the dot product. This big dot in the middle does not mean multiply, it means dot product. We learned that the last time I saw you. So if you don't remember what that is, get your notes out, flip back to the last thing that we did. The dot product is when you multiply the first terms and then add that to the product of the second term. So if I'm doing CA and BA, first thing we need to do is have both of those. So BA, I've been using this whole time, 3 comma 5, and then CA, okay, well I did AC, so we just have to go backwards of that. We're just going to do -6 and +2. So I'm going to multiply -6 and +3 together, and then add that to 2 times 5. So that gives me -18 plus 10. My dot product is always a number. It's not a vector, it's an actual value. So that's answer is -8. Unit vector of BA is, we've been using 3, 5. I tried to keep it simple on us. We don't have to keep writing the same new vector. Unit vector is where we do the magnitude divided by the vector. So good thing we already found the magnitude. That's root 3 over 4. Or, whoa, it's root 34. Excuse me, that was weird. So we're just dividing the entire vector by root 34. I do want it written out like it's a vector, so I want it to be 3 over root 34 comma 5 over radical 34. As I said in class, I don't need you to rationalize it. You can rationalize it, and if I ask you on a test or quiz, please be prepared to. But unless I specify, you don't have to go out of your way for that. All right, direction angle in or of BA. So the direction angle is where we have to use the magnitude and the vector that we already have. So we already have the vector is 3 comma 5, and then we know the direction angle is the magnitude root 34, and then like the first term, your A or your X would be cosine theta. We can just set that equal to the 3. If we wanted to do all of it, we'd do root 34 sine theta. That would be my entire vector, but we only have to pick part of it. So I'm going to do 3, and I'm going to do root 30 equals root 34 cosine theta. Let me do that in that green so it kind of stands out. 3 equals root 34. Come on, there we go. Cosine theta. So in your calculator, you're going to type second cosine of 3 divided by root 34. And then that answer is going to be, and that answer is 59.03, or just 59 degrees. All right, 2 more. Number 8, this was one we've done before. This was one that was on the quiz. Find D so that AB is equal to CD. Well, we know AB is the opposite signs of 3 comma 5, so it's going to be -3, -5. And then CD, we don't know what D is, so we're going to have X minus whatever your C value is, which was 7, and then Y minus your Y value, which is 3. And you can do these like mental math, or you can do them off to the side. So you can do -3 equals X minus 7. That would give you 4. And then we can do -5 equal to X minus 3. Add 3 to both sides. Y equals -2. So I believe your final answer is 4 comma -2. If that's wrong, if I did that wrong, let me know, but I believe that's right. Add 7, yeah. Add 3, okay, yeah. All right, and then the last one is one that we also learned the very last time I saw you, so we may not remember this. Again, I'd pull out your notes and we can kind of refresh there. It says theta, or the angle between BA and AC. So there is a formula for that. I'm looking at my notes from last class, and it says that we have to do inverse cosine of the dot product U dot V or BA dot AC over the magnitude of each of them. Magnitude of U, magnitude of V. Okay. We might need a different page for this, might we? Do we have the dot product of those two? We do have the dot product of CA and BA. The thing that would change is the signs. Let me see. Can I do this on the next page? BA and CA. And then my points. I'm sure I can't copy paste on here. We know BA is 3, 5. Okay, so I'm not going to reinvent the wheel. BA we know is 3, 5. And then CA we know is the opposite of AC. Oh no, we're doing AC. Excuse me. AC. Okay. And we know AC is on this page, and it is 6, negative 2. Okay. 6, negative 2. Okay, so we need to do the dot product between them. U dot V, or you can label it A, B, or BA and AC. I don't care what you do. So I've got 3 times 6 is 18, plus 5 times negative 2 is going to be negative 10. And so my answer is 8. So my dot product is 8. Okay, that's half the battle. Now I have to do the magnitude of both of these. So magnitude of BA, I believe that's on my other page, right? Root 34. Let's go back and check. Yep, root 34. But I haven't done my magnitude for AC, so let's do that very quickly. 6 squared plus negative 2 squared is 36 plus 4. Nope, not 34. 36 plus 4, which is 40. I know that that's 2 root 10. You don't technically have to reduce it like that, but I just think it's going to be easier. So in order to find theta, we have to do inverse cos of the dot product, which is 8, divided by root 34 times 2 root 10. You can do this a couple different ways. Honestly, I'm probably going to multiply those two in my calculator first, and then do 8 divided by whatever that is, and then do inverse cosine of whatever that is. So I'll kind of walk you through my steps. So like first, I'm going to leave it as this fraction, so it's going to be 8 over root 34 times 2 root 10, which I believe is 36.88. And I also believe if you did root 34 times root 40, you'd get the exact same answer. And yes, I just confirmed that. And so now I'm going to do 8 divided by that number, and that's 0.217. So I'm going to do inverse cosine of 0.217. And then that gives me that my theta equals 77.5. Cool. All right, so I know that that was a longer review than maybe we've normally done, but I really need you to know how to do these things. So I hope that you had integrity and paused and tried all of these things, looked at your notes. If you have no idea what's happening or if you need extra help, this is a good time to like stop and ask me, because these are things that I assume that you already know. Okay. There's just a couple other small things I'm going to teach you today. We didn't get through a ton in my A period on Friday due to plenty of reasons. And so I'm just going to teach you a couple other things. And again, we're doing notes like we normally do. So this is all going in your notebook. You can re-access this video, but like you're responsible for your own notes in your own notebook, just like we've been doing all year. So that should not be new. Okay, vocab word I'm going to teach you. Orthogonal. Okay, let me try again. O-R-T-H-O-G-O-N-A-L. Orthogonal is a fancy way of saying perpendicular. It means perpendicular, which means that they form a 90-degree angle. Okay? We use the word orthogonal with vectors. Okay, that's just the math words that we use here. And so if we have two vectors, if we have vector u and vector v, They are orthogonal if and only if their dot product is equal to 0. Okay? So if I ask you if two vectors are orthogonal, you just have to do the dot product, and if it's 0, then you say yes, and if it's not 0, then you say no. So we're going to do an example, because that's how this class works. Example, R vector V, which is 2, 3, and vector U, which is, oh wow, -6, 4, are they orthogonal? As I just stated, do the dot product. That's all I want to see. The dot product of V dot U is 2 times -6 plus 3 times 4. 2 times -6 is -12. 3 times 4 is a positive 12. -12 positive 12 is 0. So I'm going to say, yes, they are orthogonal. How fun. They are orthogonal. Okay. And then the next thing I'm going to teach you is something called projection. We're projecting vectors on top of each other. Okay. Projecting vectors. The easiest way of thinking about this is thinking of it as a shadow. So it's like, so I'm going to write shadow underneath it. We're not going to focus a ton on drawing and how they look, but I think it's interesting to see kind of the real life application of these. So if I have a vector U, we call that vector U, and then maybe I have vector V over here. The projection of U onto V is as though I drew a perpendicular line from U to V. That's perpendicular. And then it's that distance from where they connect to where the right angle starts. So it's just a shadow. If there was like a sun on top and it's shadowed down, this is a projection. Actually, I lied. This is not just called U. It's called, this is called the projection, PROJ, of U onto V. So it's like a little v subscript of the project of U. You won't have to draw these. I just think it's interesting to know what we're talking about. Okay. So now let me give you the formula to use to find whether, or find what the projection is. So I'm going to write projection of U onto V is the dot product of U and V over the magnitude of V squared times vector V. It's important to know that the projection is a vector. Your answer for this will be a vector. It's not a number, it's not a value, it is an entire vector. So you should have the little V signs and then something, comma, something else. That's what your answer should look like, okay? So we're going to do an example. In my example, we will say that vector U is 6, 2, and vector V is 5, -5. And we're going to project U onto V. And that would be in the directions. Project U onto V. Okay, so we're going to just have to do all of these pieces. We need to figure out what U dot V is, and we have to figure out what magnitude of V is, and then square that, and then we'll multiply that fraction times V. So dot product is 6 times 5 plus 2 times -5, which is 30 minus 10, which is 20. Okay, that's not hard. Magnitude of V is going to be 5 squared plus -5 squared, which is 25 plus 25, which is 50. Oh gosh, okay. Radical 50, which we know is 5 root 2. And so we're going to do 20 over 5 root 2 squared times vector v, which is 5, negative 5. 5 root 2 squared, well, 5 root 2 was root 50, so I guess technically maybe simplifying it isn't going to be the easiest step. I just like to clean things up, but that doesn't mean that it's easiest. I'm going to actually do this over on this side because there's a little bit more room. So it's like 20 over root 50 squared, and the square root of a radical, like I just taught my geometry kids, is itself. So it's like 20 over 50 times 5 comma negative 5. I would rather simplify before I start multiplying things, so I'm going to get rid of the zeros. So now I've got 2 over 5 times 5 comma negative 5, and it looks like there's 5 in both of them, so I'm allowed. I have no idea when that video stopped, but I kept going. I'm sorry if you missed something. If you have a question on what you missed, I really think it was only paused for a second, but I'm so sorry it paused. I must have done something, my fault. But I think that's it. So I taught you 2 things today. Well, first we did a giant review, so check the first 2 slides if you need to review, and then after that I told you about being orthogonal, which is perpendicular, and then I taught you about projecting vectors, and so I did an example on that. I will make sure that the homework questions reflect what we learned today. We did not do any force or work problems, so I'll take those off and we'll look at those another day. And if you have any questions, let me know. Have a good day, guys. Bye.